Okay, so this is going to be a quick 1-hour presentation of some JavaScript code. The aim initially was to do some hands-on work, but 1 hour is really short. So I'll walk you through some code, and sort of the aim is to show off some of the features and quirks of JavaScript as I do so. So I wanted to do the equivalent of a hello world for JavaScript applications. And the typical application when you do JavaScript is the client-server application. And the small, trivial application we generally go to is a simple to-do application where you can add to-do elements, remove them, check them as done, not done. So this is kind of the often the go-to example for client-server applications. So that's what I'm going to do. Both the client and the server will be running in JavaScript using Node.js for the server. So as I said, for those who want to grab the code and follow along, I gave you the instructions here. They're also, I think, in the link. You'll find them. So quick note about the project. So as I said, it'll be a very simple front end with a to-do list where I can add and remove items. So I actually embedded it here. Normally it works. So I can add stuff, remove stuff, check stuff, and then I have a magical button to clear everything that's been checked. So this is the whole application. And the data will itself be hosted in the backend, meaning if I have two clients connecting to this application, they'll see things move together, be working on the same data. So that's the application. So the project structure for those who downloaded it and for others who want to keep on, you'll have the server is a JavaScript file, as well as a module I'll import. This is primarily to showcase important modules. A lot of the decisions I made were also to showcase language features and not necessarily how I would do it. But yeah, that was the aim. And then in public, I have the client with the index.html and the client.js file. This is what you need to worry about. Here's the NPM stuff for all the modules that will be loaded. That is to say one module, and then the presentation for those who downloaded the Git. But really, these are the 4 files you need to worry about. 5, if you include the package.json, which describes the server. Sorry, if you think of the server as an app, package.json is sort of the app manifest, which you'll generally have as soon as you do Node.js, which namely has all the dependencies declared inside. So quick word about the application. I'll have a very simple backend API. So it's a REST API with just getting and putting data. I don't really want to go through it, but it's really what you'd expect. The only interesting thing is that we have a cleanup call we can do, which will ask the backend to sort of remove everything that's been checked. So that'll be done on the backend and not on the front end. And we'll see that the application actually sends instructions to the backend and then just refresh it. It's not a full page refresh. We'll get to this, but that's basically, it's really trivial and not necessarily optimized. So we'll start with the backend server. And for that, as I said, Node.js projects, they have what we call a manifest. So a package.json file, which describes, there are many things we can put inside, but the most important one is probably dependencies. So here we only have actually one dependency which is expressed. It's the Node.js equivalent of Flask, if you will, because we're building a server. This is just to serve the documentation for those who want to run the documentation. I added that in there, but it's not used by the application. Scripts are an easy way to have sort of to declare the entry points of your application. If your application has a build phase, if there's different ways of running it, especially development versus production, you can have all your scripts there, and then you just do npm run your script, and it'll do that. So it's a neat way of having all your functionalities in one place and easy to use. And of course, you can add all sorts of extra stuff in there, license information, author information. It really describes your application. Generally, when you create a Node.js application, you start by doing npm init -y to just create a blank Node.js project, or you grab an existing package.json, which tells you what you'll need, namely your dependencies for your application. So here we have one that's already provided in the Git. So we can just run npm install, and that will install all the dependencies in the Node module. That was not pushed to the Git. If ever you want to add dependencies to a project that are not yet in the package.json, you just do npm install your dependency, and it'll be added in there. Last thing, there's a package lock file which is created, which actually freezes version numbers. This is important if you don't want people to be retrieving the wrong version. You want to be able to freeze it. It does that by default, like 5 years ago. So that's all we really need to know about the package.json. And now we're going to start with the data structure, actually, to hold our to-do data. So this is the data.js file, not the server file itself, the one we'll be importing. And it will be basically creating a class to hold our data. So this is really trivial. Interesting things to notice. Export. Unlike Python, you actually have to explicitly export things from your modules to be imported elsewhere. Python is more, you have to explicitly not export with underscores. But apart from that, it's a data structure like you would expect. So obviously, this is the first line of code. If you've never seen JavaScript, it's C-like syntax with curly braces everywhere, and stuff like that. So we'll do a pretty simple class structure. The other thing I wanted to sort of show, the other things, private attributes use hashes. This is just not just a convention. It is enforced by the language, but that's the syntax they use. Don't ask me why. More importantly, something I want to insist upon, JavaScript has two equivalents of the Python dict object, the dict structure. It has object and it has the map structure, the map class. And they tend to be used in two different ways. Map is really for dynamic, homogeneous key value pairs, where you want to be inserting and removing elements with keys. Whereas objects are really more structured data, where you have generally fixed or expected keys. You won't be inserting dynamically generated keys with objects. So they tend to be used differently. Maps are rather recent in the language, meaning for a long time, objects were used as maps as well. So you'll see legacy, the code that does that a lot. But there's really these two structures that, even though they're both, in a sense, key value pairs, are used in very different ways. So maps would look like this, and objects tend to look like this. If you've seen JSON syntax, basically, JSON is JavaScript object notation. So this is what our class will look like. And I'll just walk through the method definitions. So our data will hold, just before I move on, an ID, a name, and a Boolean that tells if a task is done or not. So the constructor, so this is the equivalent of the init function in Python. Here I start off, so I didn't necessarily choose the features in a simple to hard order, but more in the order they came up through the code, walking through the code. So here we have,
there's two questions from Marco. The first one is, what is express?
As I said, it's the equivalent of Flask.
And the second one is why the map is allocated outside of the constructor.
Okay, so this is something you can do. You can either declare it in the constructor, or for anything that's doesn't depend on your parameters, you can actually declare them prior to that. Something you'll find in a lot of language to be able to initialize attributes outside the constructor. The initialization doesn't depend on parameters. In fact, in JavaScript, you don't even need to declare the attribute outside. You could only declare it inside the constructor. And that would work as well. I have a doubt with private attributes. But yeah, you could. There are different ways of doing it. You can place it outside or inside. This is for legacy reasons again. I just do it like that. That way, and see what my class looks like.
A follow-up question by Marco: what is Flask?
It's like Cherry Pie. It's like
And Cherry Pie is like Express.
It's like framework from web.
Yeah, it's basically your 101 web server for Python. That does a web server for you. That simplifies it. I don't know if you.
Yeah.
Yeah, it's more framework because
it's
not just
no, sorry, not. It allows you to declare your web API or web backend in Python.
It's like a small Django.
Django is a big class. Okay. Okay. So I hope that answers the question. Yeah, it's a web API framework. I'll use it.
Complaints so far, so
I'll use it later, so you'll see what it looks like. So moving on. So in the constructor, I've already forgotten what those are called. The triple dot notation here is a spread operator. So it's the equivalent of using a star in Python to have multiple parameters concatenated into an array. You'll notice we use this instead of self because conventions. So basically, the constructor takes data as parameters. They arrive in an array, and our constructor is just going to take the default task we start up with. So each of them is going to be a string, and for each of those strings, I'm going to basically add them to my data structure with the add method. So interesting to notice, we use functional programming generally in JavaScript, so we'll use the for each and provide a function rather than iterate on the array. I have a slide right after where I show all the ways of iterating, but most often you'll see the use of for each to iterate on an array. And the other interesting thing is the function itself, which is declared inline. So this behaves somewhat like a Lambda function in Python, but these arrow functions, we call them, are a little more powerful. You can have multiple statements, and you can have full-blown functions. But one of the nice things about JavaScript is it allows you to declare inline functions like that to use as callbacks. Because often in Python, you'd have to declare a function and then use it as a callback. And here it keeps sort of the logic self-contained in the line, which is neat. Arrow functions don't work exactly like functions, but I don't really want to get into the specifics. Yeah, I'm gonna skip that. They're a little separate in how they work, and namely in the binding of certain variables, including a this variable. A function, if you declare a function, declares a this variable local to that function. So this wouldn't work because we had the wrong this if we declared a full function and not an arrow function. That's more the obscure stuff. Use arrow functions. As I said, a quick aside on iterating over different types of data structures. So of course, you can do your basic for loops, both the very old school for loops. You can iterate with let I in array or of array to iterate over the indexes or the values of an array as well. But the more conventional approach is to use array for each or an array on an array. You have other means of iteration. The other very classical one is map, which for each value in your array will apply the function to that value and return the array of outputs, which is used a lot. This is what will basically, this and filter together replace list comprehensions in Python. Filter being returns the array filter. So with those two, you basically have all your comprehensions. And this is the go-to way in JavaScript. And you can do the same. So iterating over objects is a bit different for, again, legacy reasons. Objects were built completely differently. But you have functions which allow you to retrieve the keys, values, or key value pairs as arrays, which is very which basically brings you back to the previous case, or you can iterate over the key. However, if you do that, there's a lot of, basically objects have built-in key values, which are hidden from enumerations. So you're actually not enumerating all the key values. And in some weird cases, this sort of behavior can do odd stuff. So you probably best to stick with stuff like this, have an array. And maps allow you to iterate directly on the key value pairs, have a for each function as well. They don't have other functions like map or filter, but they do have the equivalent of map.keys, map.values, and map.entries, which allow you to convert back to arrays, or actually not quite arrays, iterators. I won't go more into detail. We'll have examples of this later on, starting here. So I'm moving on from my functions in my data structure. So has and get are pretty straightforward facet functions for the map structure we have. What's interesting here is that get returns undefined if the item is not there. This is important. It doesn't raise an exception. And it also allows me to specify that JavaScript has actually two null types, undefined and null. Undefined is really when something doesn't exist. Null is when it exists, but it hasn't been filled in. So if you're intentionally setting a value to not filled in yet for some reason, you want to use null. If something is supposed to not be there, you want to use undefined. This is sort of more of an art than a science. And people kind of use one for the other or not. But it's one of the interesting quirks I wanted to mention. The other thing here we see is the get all function, where, as I said, I'm using the values method on the map data structure. It returns an iterator, and iterators don't define all the methods I may want later, so I just want to return an array and not think about it. So I use the spread iterator, the spread operation, and brackets around it to transform my iterator to an array. So this is the sort of syntax you'll sometimes find. It's just a simple conversion. Yep.
To be clear, here what you return is only the value you use
If you recall, I actually put the ID inside the object because I didn't want the ID that I'm going to use here is also here inside the value. The key is in the value. That way I can just not worry about it. This is the reason I do this is that when I'm going to send data over the network, I'm going to send it as JSON. JSON doesn't have maps. It has objects, but it also has arrays. I'm actually going to send the data as an array of to-do elements with inside each element of the array, the ID, the name, and the boolean. Not necessarily the best choice, kind of the easiest one. So I wanted to move forward. Okay, interesting one is when we want to add something, I need to draw an ID for that element. So here, this is the thing that was getting Maxime's code to crash. I import from the built-in module crypto a random unique user ID, random universal unique ID function, which I rename as UUID. So this is the equivalent in Python of from crypto import random UUID as UUID. What's interesting is that we use object destructuring, and I'll show more of this later, to retrieve the items. Crypto returns an object, all of the methods inside of it. And I'm just destructuring that object and grabbing that one item I need. And then I'm going to use UUID to grab an ID. Two other things, three on that slide that I want to show off. Template strings. So if you want F strings in Python, the equivalent is template strings in JavaScript, where you can insert directly variables inside the string. They use backticks. If you use double quotations or single quotation marks, you won't have access to that. They can do multi-line, and you can even have a weird way of applying functions that I don't show off here, but this is sort of the f-string equivalent that you get to use quite a lot. We'll have other examples. Here, when I create the object, so I use set to create the first object, then it's initiated to false. I grab the name that was sent by the user, the ID I just created. You'll notice I don't have to do ID colon ID when I add the ID. We have a shorthand, basically. If I just say ID, it's a shorthand for ID colon ID. So that's about it. And last thing, so here I use const. There's two ways of declaring variables. Const, which says this variable has been assigned, it cannot be reassigned. Doesn't mean it cannot be changed. And I can call methods on the variable that change the state of that variable. I just cannot reassign it. If I want to be able to reassign it, the keyword is let. That's it. And I think we're almost done. There's not a lot to add here. It's just me filling in the last functions. Yeah. Oh yeah, cleanup. So this is the function that'll be called when I do the remove done button, which has to filter through all the elements and remove the ones that are checked. So in order, first thing I do is I iterate over the entries. So over this.data, I need to be able to filter the filters. So I can't use directly the iterator or the map, which neither of which has filter assigned to it. I need an array. So I do the typical conversion to an array, filter those so to only have those that are done, and then for each of them that are done, I just call this.remove. You could do this differently by reassigning this.data with this.data.filter, not done. One of the reasons I did this, second, you could probably use get all rather than redo that spread operator. One thing I wanted to showcase here is that semicolon at the start of the line. If I don't have that semicolon and I have a line that starts with a square bracket, Python thinks it's a continuation of the previous line and is going to try and access an element from whatever console.log returns, as if it were an array. So semicolons are completely optional in JavaScript. You don't have to add them at the end of the line. It does it for you. Sometimes you need it to clarify. And generally, the common practice is to put it at the beginning of the offending line. That way, if we start moving things around, the semicolon moves with the line that actually poses the problem rather than being stuck with the previous one. I'll show another example of this with commas later. But it's common to see that semicolon there because that's the line that poses the problem. But if you want to think of it as at the end of the previous line, because that's the syntax you're used to, it's the same thing. Is that clear? So yeah, this is one of those things you'll cross and you want to know what you're dealing with. Yeah.
Isn't it a problem to change the map we are just iterating? Because it's something usually you don't want to do in many languages.
Yeah. So once again, I try to keep it simple and not actually do it as optimized as I want to. Here, I'm actually with the spread operator. I'm actually grabbing the values outside. Okay. So I'm basically duplicating, iterating over it, and then changing the original one. And with the synchronicity we have in JavaScript, there's no race conditions that may happen at that time. But yeah, you could easily do it differently. There's no filter on the map itself. It would probably be best if you want to sort of avoid to have to think about that to reassign. So grab the map, filter it, and then reassign it to this.data. But yeah, I wanted to showcase the semicolon, so I did it that way. So we have our data structure we've exposed, which is basically one data class that'll hold our data. And now I'm going to create a server, server.js. How far back I'm kind of like, oh yeah. So server.js is basically going to import our data structure. and create new data with two items, the ones you saw when I started the presentation. I'm also going to import Express, so my web server framework. First line, I just wanted to check that in there because every time you want to use environment variables with default values, that's what it looks like in code. So this is just saying either the port was provided as an environment variable or there it is. I have imported my web framework. I created an app from it. And then this is just Express syntax for defining endpoints. This here just tells Express that everything that's in the public folder should be served as is. So this is basically static files. The public folder is the one where I have index.html and client.js. So this is going to serve my page itself and the JavaScript, and these are the REST endpoints. And then I'm just starting the
Question for Marco. Why is there curly braces around data in the imports?
Because it's where it's object destructuring. Data, when I do import from data.js, what I'm retrieving is an object containing all the exported methods or classes or things like that in an object. If I want to grab one item in that, I just destructure that object and grab that item. It's what we did when we imported a random UID from crypto. So you have to destructure it that way. Otherwise, you could do what I did here with express and not, then you curly braces, then you'd have an object containing your data field, and we'd have to do object.data to grab the class. Not a lot I want to add here, so I'm going to fill in these functions. I don't want to get into the details of Express. The only interesting thing I'm doing here, so when I get data, I just send back the data retrieved from my data structure. When I post data, I'm retrieving the text data that is sent. Basically, when I do post to data, I'm setting a new item where I'm just sending the new item's name. I don't have an ID, I don't have a done value, so it's just text. Express can parse the body an HTTP request, but I have to give it a middleware to do that. So here, Express will see that it's a text plain payload, and we'll use the middleware I declare here at the top to actually parse that and put it into the body field. This use of middleware is very common to sort of allow to introduce new functionalities inside the framework. That way, it doesn't have to have everything. It doesn't have to be able to parse XML if I don't have XML or stuff like that. One common pattern I sometimes use for debugging is just a middleware that logs all requests. So this is a homemade middleware, which will just, for every request, log the method and URL and then move on through the chain of execution. I don't want to get too much into Express, but this is a common pattern you'll see with other frameworks as well. So I just wanted to put that in there. Other things, so same thing, I'm going to use JSON for if I have JSON formats, namely, if the done value changes, I'm going to send an HTTP request with a JSON string containing the done value. So I need to introduce a JSON middleware to parse that. Also, here, when I'm retrieving the ID, it's found in rec.params.id. I can do destructuring as well. So here I did two different approaches to show that there are different ways of retrieving data. Generally, you'll use the first one, except if you have multiple things you want to get inside that object, multiple variables, in which case you'll destructure it to directly assign those variables in one assignment. You can actually take it a step further and say, I need three things here in my request object: params.id, body.dom, sorry, two things, params.id and body.dom. You can actually destructure that object directly in the function call. This is something you'll see a lot. So not with embedded ones like this, but I'll show it later. A lot of methods which take in an object as a parameter, and that object has just a few fields they need, will directly destructure that object in the function definition in the parameter. And you gain in readability. It's more concise. Yes, the rest, I mean, there's a ternary operators are the right way around. The only language that doesn't put them in this order is Python. So there you go. And that was a pre-shot at Python. And that's about it for there. So we have now the server is fully written, data structure and the express. You have a question?
Yes.
Always.
I think on the previous slide, I guess there is a typo. This should be curly brace params colon ID, not parenthesis curly brace params whatever. Yeah, in the last line, I guess.
Nothing's okay.
Where is it? I need to see what they wrote.
So I think Marco does not understand why is it parenthesis here and not a second.
All right.
Opening.
Sorry. Here, when you have in an arrow function like here, if you have multiple parameters.
Show on your screen, please, with your mouse.
Yeah. Here, when I have multiple parameters, I need to put parentheses on it, and those parentheses are the ones that we find here and here. My first parameter itself, just here. So the structuring, there's no parentheses at that point. I'm just destructuring one object, and inside that object, destructuring two objects. Is that more clear?
No complaints so far.
Okay.
I guess it.
So we'll move on to the front end.
Yeah, it's okay.
I wanted to talk about HTML, so I did the bare minimum HTML and live with that. Basically, the only thing I really want to point out is the defer keyword in the script loading. This tells the web page, sorry, the web browser to load, to execute, sorry, the JavaScript once the whole page is loaded. For a long time, there was the things where the JavaScript would execute automatically before the rest of the page was loaded. If my JavaScript sort of refers to things that were in the HTML, it would fail. And so people started putting the script at the end, that way the script would load last, when it should be in the header part. So eventually they added that keyword to say, just do it last. So you want to do that, otherwise it'll fail. But then we have just a title, an empty list for now, and then our input text when we want to add something with a button, and the clear finished button. That's it.
By the way, this differ, it's standard law because I remember previously you had to encapsulate onload to do this.
Yeah, that's basically Differ does that for you now, and it's been around for a few years.
Okay.
Yeah, no,
it's still.
yeah. Basically, that what you described there is the reason they added it, because it was just
it had one level of function.
It replaces the on document flow that was used all the time to say once everything's loaded, then do this. So there's nothing much here. This list will populate. So we want to populate it with something that looks like this, where we have list items, including an input checkbox, check done items, a label where the item's name appears, and a trash can for removing that item. Okay for everybody? And then I've just put IDs in there so we know where we are. So we can move to our client and sort of do the jobs. The first thing I'm going to do is I'm going to grab the two fields I'm going to need, sorry, two tags and nodes I'm going to interact with all the time, which are the list, which I'm going to have to repopulate, and the new name field, which is where I'm going to add text. So I need to sometimes grab that text to know what the user put in. So at this point, I'm going to separate the function I defined into two parts. The render and refresh function. Render is in charge of actually populating the list, and refresh is just a call to the network, what's in the list, and then call render. And I'm going to call refresh and then use set interval to call refresh every second. So this is in milliseconds, call that second. There's also a set timeout, which does the same thing once. It says in 1 second, call that function and then stop. But the common way of doing something every second is to use a set interval function. Very handy. I'll come back to everything I'm doing wrong at the end, because I'm doing things wrong to make it simple. And then we have the add function, which will be called when I click the add button, the onChange function, which will be called when I toggle a checkbox, the remove function for the trash can, and the cleanup function for the cleanup button. Clear for everybody? Okay, render function. So here I'm going to take a very big shortcut in terms of optimization, and I'm going to say every time I retrieve the list, I'm going to recreate my whole list in HTML. Don't do that. It's a shortcut. So the correct way, in a sense, and I'll sort of explain why I'm saying that later, would be to create every element in for every item in my list of elements. So, sorry, data here. I'm going to map over it. For every item where I have, so the ID, the name, and status, I'm going to create a list item. And inside that list item, I'm going to add an input, a label, and a remove link. I'm basically populating all those things. It's a bit tedious if you do it that way. At the end, I have a list of all these nodes that I've created. I'm going to say the list container, so the UL tag. I'm going to replace its contents with the elements I just created. A lot of people don't like doing this because it's a pain in the ass, and would rather write something like this, which basically says, for every element here, I'm basically going to write as a template string the HTML code I want to put it, join that code. So I have an array, I'm just going to join that array into one big string, and then list container.inner HTML provide that string. This is a lot easier to write. So it's a lot slower because the web page actually has to parse that string into HTML, whereas in the previous case, it has the actual DOM structure in its internal representation. The correct way of having the best of both worlds is to pre-process, is to use a preprocessor where you write this, and offline it will change it into this for you, and then you serve this, but you don't have to write it. But that's what I talked about last time, and it's not something I want to showcase today. The rest of the functions. So the refresh function is the one that calls that retrieves data from the server and then calls render. And so it's a fundamentally asynchronous function. We have data, a network call. And so here's where I showcase async await function functionalities in JavaScript. So first thing, compared to async.io in Python, I don't have to import anything, it's built in. I have to declare a function as asynchronous, and then I can await every time I do an asynchronous call to say here, wait for the response before moving on. So fetch is now the basic way of doing an HTTP request. If you just provide a URL, it will do a get to that URL. One of the surprising things for people is that fetch fails if there's a network error, but if it receives a 404 or 500, it will not throw an exception, not fail. It will just return with the error code. So we have a nice res.ok check to see if the error code is less than 400 strictly. If not, we'll throw the exceptions. That way, network exceptions and something went bad on the server side both end up in the try catch and in the catch. And if not, I'll retrieve the JSON from my response. So fetch has the JSON API to, if it's JSON, parse it. That request is asynchronous for reasons, so I have to wait it. Now I have my list of sorry, I don't remember what the data structure is exactly. I have my list of items, and I retrieve the values. Why is it object of values? Doesn't matter. I just call render here at the end to render my values. So I recreate every second I call the server, grab the values there, and re-render my whole list. The async await syntax is actually rather recent, maybe 5 years. And before that, we had promises, which was the built-in method of doing this. And async await is actually syntactic sugar for promises. What that means is that fetch actually returns a promise, and when I call await fetch, I'm awaiting for the results of that promise. Before that syntactic sugar, fetch would return a promise object, and I would have to call then with a callback to do something with the result once it arrived. And I'd have a catch callback as well, so a catch to register an error callback. Those two codes are really equivalent in how they're running, and you can mix and match promise written functions and async await written functions. Both syntaxes have their pros and cons. I've been used to this one for a long time. I'm moving to this one. It really depends what you're used to. One last thing, especially since we had the presentation for Python, there's a big difference between async.io and this. Here, if I call fetch and retrieve the promise object it returns and then later await it, the code will start running when I create the promise object, even if I only await it later. Whereas in async.io, I have to await it to start running the code. How late am I? I don't want to go into all the details of like filling in the code. When I want to add something, so when I click on the add button, first thing I'm going to do is I'm going to retrieve whatever was in the new name field, text field, to know what I'm adding. And do a fetch. So now this time I want to do a post. So I actually have to provide an options object to the fetch call with the method, the body, which is going to be text, header, which says it's text. That header is important because if you recall in the server, I had a middleware which said if the content type is text/plain, parse it and add it into the request body. This is necessary for the server to know how to parse the content. Same thing with the response, and then I call refresh and I reset the field, the text field. Two things I want to say here. First one, this comma. It's important. Why is it important? You can do without it. You can not put it there. But if you start moving lines around, all the time you're like, oh wait, I have to move that comma there. If I add that comma, which is free, I never had that problem. And it's very common practice nowadays to just have that trailing comma in lists as well. It's kind of like the semicolon at the start of the line. You add it where it's great. If it moves around, it moves for you. So you lose it. The other thing, JavaScript does not have named parameters for functions as you would have in Python. So if you have options to provide to a function that are all optional and named, the common way of doing this in JavaScript is through an options object as a last parameter, which is what fetch does. You provide an object which has all the functions, and all of those fields are optional. There are other fields, and this is how you provide named parameters in JavaScript. And generally, if you want to write a function, I didn't provide it here, that takes an options object as a parameter, you'll have a default options object as well, and you'll actually create an object spreading the default object and then the provided object, the second one overriding the first one, and it'll just work out for you. Yeah.
Can you go back to previous slide?
I can.
Previous slide.
Again.
So in fact, I hadn't seen the question and previous one again. Yes. And question from Marco: why do you add li in document and not directly in list container?
Oh, document.create element.
Yes, I think so.
Create element creates a DOM node. It does not add it to the DOM. So it's the method is provided by the document object in JavaScript. Document.create element does not create an element inside your DOM tree. It just creates a node that's free floating somewhere. And then you have to insert it somewhere with append child. So I could not do list.create element li and assume that it's in the list. It's not there yet. So I hope that answers the question. So where was I? I was here. Same thing here, not a lot to add except I'm doing JSON. JSON stringify to create JSON strings. JSON parse to parse JSON strings. Built in, not much to say there. You'll use it a lot. And this is just me filling out the last methods, not much to it. Okay, yeah. Any questions there before I start doing the optional stuff?
I think for the, yeah.
Okay, a few common practices that I haven't mentioned. When I do my code here, all of these are being included in the global scope of the HTML page when I loaded my script. So if I'm loading 5 scripts and 4 of them have the add function, they're overriding each other. There are multiple ways of correcting this. If you only want to expose certain things, you will generally create a function where you have all your code, return only what you want, call that function, and then retrieve those things. So here I'm still exposing add, so that was a bad example. But if, for example, new name field, which doesn't need to be accessed outside, will be scoped here and will not be made available in the global namespace as it was prior. So this approach, which we call immediately invoked function expressions, are basically the most common means of scoping variables in JavaScript. There are other ways of doing it. Here, I still have 4 functions which are made available. If I want to move it to 0, I can actually have a function that doesn't return anything. But then I have to, for the, if you recall, sorry, I have to show the HTML again. If you recall the HTML, I had 2 functions which needed to be accessed from the HTML. If I don't want to make them available and I want to really scope everything, then I actually need to, in the code, grab those elements and add the function on my own. This is something you'll find a lot. Now I'm not exposing anything. Everything is scoped in my. For awkward reasons, we need parentheses around the function if it doesn't return anything, so that JavaScript knows that it's a function expression and not a function definition. And since we have parentheses, I need a semicolon. Otherwise, if there's something prior to that, JavaScript thinks it's the continuation. Another way, more recent, of doing proper scoping is using type module when you're loading a script. This tells JavaScript it's a module and only exposes what it expressly exposes. And since HTML doesn't have any way of actually using what is exposed properly, so it doesn't name the object that's exposed, it's actually completely scoped. So you could just do this on a script that way, not pollute the one namespace. I'm pretty done. So here's our thing in action. I don't know if I want to play around a little much, but this is our application finished. I have 2 more slides of extras beyond that. Really quickly. Yeah. So what did I do wrong? It's the first one. Pulling every second to the web server is not the recommended way of doing it. Today there are 2 classical means of doing this. One of them is long pulling, which basically is doing the same thing, but I do my request, and the server, if there's no update, will not reply like 5 seconds. If ever there's an update, they will reply immediately. Otherwise, after 5 or 10 seconds, they'll say, actually, no update. And only then will I start again. And I'm basically opening a TCP session, allowing the server to reply whenever they want to, but only really getting a reply when there's an update. So this greatly reduces the network calls. The other method which I recommend is WebSockets, which is really opening a socket bi-directional communication. And so I'm telling the server they can tell me anything whenever they want and initiated by the server. There's a great JavaScript framework for that, which is Socket.io. I didn't put it up there. But those are definitely better methods for doing this. Note, however, that I did not refresh the page every time, because that's even more barbaric. The other big thing I do, which is not great, is recreating my whole list every time. Ideally, I'd want to remove nodes which are removed and add nodes, but not touch the other ones. So there's a lot of frameworks that do things like that. They use what they call a virtual DOM, which is they have an inner structure of what the data object model looks like and know what to change when there's updates. Some of them actually look at the DOM directly to make the updates. Others, for performance reasons, really have this virtual DOM to sort of have a copy. The reason being that the DOM itself is managed by the browser. So interacting with the DOM is basically a system call, which is a lot slower than if you have a local representation of the DOM, which you're working with it and only updating the DOM when you know you need to update it. So those are the two big things. Third thing, obviously, storing data in a database on the server side. I didn't want to do that code here, but you probably should do that. So that's just me saying, yes, this is not how you want to do it, but this is a tutorial. And things I didn't cover because they didn't come up. Equality operators. JavaScript, you have two common equality operators, 2 equals and 3 equals. Basically, I haven't showcased this much here, but whenever it can, JavaScript tries to cast types. If you're asking it to add a string and an integer, it will cast one of the other into the same type. There are weird things you can do with that. Basically, you never know if you're adding the string 1 and the number 1, you never know if you're adding 1 and 1 as numbers or as strings. And you shouldn't assume. I mean, there are rules, but you should not assume. Basically, equal will try to cast types. 3 equals will not, and will say if they are different types, then they are not equal. And will not try to do type conversion. So you should always use 3 equals, basically. And same for the inequality. Another interesting thing, which is more recent to Node.js, 2-3 years now, is the optional chaining operator. This is really convenient when you have something where like you want to get the value in a map based on a key, but if the key is not there, then this will return undefined and this will fail and your code will crash. So you'd have to have like a test to see if the value is there, then retrieve it, check if it's undefined, then get the value. And what optional chaining does is basically says, if at this point I have undefined, I'm stopping and I'm returning undefined, otherwise I'm continuing. So here I'll have undefined or the value without needing any more tests. This is syntactic sugar, which makes code a lot easier to read and a lot more precise. And then a lot of stuff. Iterators, I mentioned there are some generators, things you'd expect in the language. Scopes and closures, there's a lot of interesting, I didn't mention it, but it came up at one point in the middle of the code. When you define a function, it freezes the variables it knows at the moment of its definition, not in terms of values, but in terms of what those variables are. And if you call that function later in a completely different scope, it will say that what is called a closure. Those variables are the ones that it will be referring to in its code. Something you can get caught up with a bit, but it has a nice way of scoping variables when you define functions, which avoids sort of the problems you sometimes have with global in Python and things like that, which are very, very important, I find. Symbols, when you want a string that's been defined once and only once in your code, basically, when you really want a unique key that cannot be replicated, key value pairs, namely. And strings, which are used a lot, but I didn't have to get into that. Okay, classes and objects and inheritance are weird in JavaScript. Basically, a class is an object. So inheritance and the way it works is when you use it, it looks the same. Behind the scenes, it's very different. And so when you're doing complex inheritance, things get messed up a little bit. Use the class. So again, the class keyword and the way I declared a class is actually rather recent syntactic sugar over something which was far more ugly previously. Use that syntax sugar and don't worry about what's going on behind the scenes. And then web workers, service workers work. That's all client-side stuff. I think this is all the ways of doing things in the background on the client side, which is things you want to do without like freezing the browser or stuff like that. If you've ever had a frozen browser because of a page, it's because they don't know how to do this. And client-side storage, you can store data in the browser as a page, not just cookies, but more complex stuff. And this is really useful for some applications to avoid calling all over the place. And I think my basic last slide is there's also the quirks and the things you don't want to see in a language that show up. So this is sort of like a horror museum of JavaScript. I'll let you walk through it. And
yeah, the second one is actually in every language.
I don't know if
floating points are supposed to be, not a number is supposed to be different from any floating.
Yeah, so the one this one is weird, but you have to, this one, if you want to understand why it's true, you have to like iterate 5 steps of how it decomposes that. It's basically type casting, and I'm not even trying to remember exactly because basically one of them is typed as one of these arrays is cast as a boolean, the other one is an integer, and that messes it up when it recasts behind it.
Can you tell me again what's exclamation mark?
Negative. No.
What does that mean? It's not a list.
Not a list? I don't know, cast a list of boolean and see. There's no reason you couldn't cast a list to boolean. So yeah, that's automatic typecasting is a thing in JavaScript. It's error prone. It's something we can't change because we basically are have our hands tied due to legacy features. So you should never write not a list.
But if you can cast, makes sense actually, because empty list is equal to broadcast not to empty list. So it could make sense.
No, it doesn't broadcast it. It converts a list to a boolean. I think this list is converted to boolean, which is not it, and this one is converted to integer, and the boolean and integer conversions don't line up. Basically, something like that. No, I like this one a lot.
Yes, this one is nice.
This one is typical, something weird is happening. And this one, however, is one you probably should know. Due to the history of JavaScript, the sort function was conceived by people who thought it would be used on lists of strings. So it converts everything to a string and then compares. You could provide a function as a parameter.
That converts back to integer.
No, that gives you a comparison function. Yeah, one thing I didn't say, I'm realizing here is, unlike Python, you can provide any number of parameters to a function. If it's more than what that function expects, those that are left over will be dropped. If it's less, the function will have undefined as its extra parameters. There's no arity checking on the function. This is sometimes very convenient, sometimes error prone.
It's like a quirks on steroids.
I had times where Python phoned me because I wanted an optional number of parameters. And there. I think that's it, yeah.